Good day everyone, my name is Kate Tobided of BS ECE 3A, and today I'm going to present to you my performance task number 5 in ECE 23. The discussion for this performance task will cover digital modulation, GMSK, AIS modulation using GMSK. So what is digital modulation? So it uses discrete signals for modulating a carrier wave. It also minimizes internal noise as well as providing immunity to external noise. It also provides higher capacity for data, security and accessibility. As previously learned with reference to Module 5, we have other variants of digital modulation schemes. We have MSK, and one variant of that is GMSK. We have TCM, DPSK, DQPSK, and DBPSK. Now, what is Gaussian minimum shift keying? So it is a form of modulation based on FSK that has no phase discontinuities and provides efficient use of spectrum as well as enabling high-frequency radio amplifiers. And by the way, the full title of GMSK is Gaussian Filtered Minimum Shift Keying. And it is a form of frequency modulation used in radio communication system. So probably it is widely associated with the 2G GSM mobile communication system, where it proved to be an effective form of modulation and also was one of the reasons of long battery life in view of high efficiency and that could be obtained from RF powered amplifiers. Now, basics of GMSK. So, GMSK modulation is based on MSK, which is itself a form of continuous phase frequency shift keying. One of the problems with standard forms of PSK is that sidebands extends out from the carrier. To overcome this, MSK and its derivative GMSK can be used. So, MSK and GMSK modulation is also known as continuous phase scheme. And here, there are no discontinuities because frequency changes occur at the carrier zero crossing points. So this arises as a result of unique factor of MSK in that the frequency difference between the logical 1 and logical 0 state is always equal to half the data rate. So this can be expressed in terms of the modulation index, which is always equal to 0.5. And now let's see the power spectral density waveform. So a plot of the spectrum of an MSK signal shows that the sideband extending well beyond the bandwidth equal to the data rate. So this can be reduced by passing the modulating signal through a low-pass filter prior to applying it to the carrier. So the requirements for the filter are that it should have a sharp cutoff, narrow bandwidth, and its impulse response should show no overshoot. Okay, so that ideal filter is known as Gaussian filter, which has a Gaussian-shaped response to an impulse and no ringing. So in this way, the basic MSK signal is converted to a GMSK signal. Now let's see the generating GMSK modulation, and there are two types. It's using VCO and using an IQ modulator. Using VCO, so basically there are two main ways. So the most obvious way is to filter the modulating signal using a Gaussian filter and then apply this to a frequency modulator, but it has a drawback that the modulation index must exactly equal to 0.5. So in practice, this method is not suitable. Second method is more widely used, and here is what is known as a quadrature modulator is used. So the term quadrature means that the phase of signal is in quadrature of 90 degrees to one another. So the quadrature modulator uses one signal that is said to be in phase to this, take note, in phase, and another that is quadrature to this. Now let's discuss about the actual electronic system or technology that uses GMSK. We're going to discuss about AIS modulation using GMSK. So AIS is an automatic identification system, a navigation system that ships use. They have a transponder on the ship and sends out information from its GPS or its navigation systems to notify nearby vessels that it's around. So basically, you don't need a radar on an AIS screen because you can see the transponders of all the closed vessels. It's similar to an ADIB system used in aircraft reporting. Now you see we have a small RTL-SDR receiver with a small antenna, as you can see. With the right software, it can be used to receive and decode these signals and plot ship positions on a map. Now AIS uses the GMSK modulation method, and this method is excellent for nonlinear amplifiers because it has a very clean spectrum. There's very little out of band components, and there are no discrete lines. So here's a slide describing this. I got my data from the specification for AIS recommendation ITU M1371-5. So here's an information about AIS. I'll just summarize. It was invented by Haken-Lutz. Similar to ADS-B for aircraft, it uses two VHF channels, 87B and 88B at 161.975 MHz and 162.025 MHz. It also uses GMSK modulation. Data rate is 9.6 kilobits. Now, the MSK modulation system, the way it works is that the frequency shift is half the data rate, which gives us excellent results with no discrete lines. And then the Gaussian filter smooths the data so that you don't need to get out of the channel information. So it also uses SOTDMA, the different classes of stations, Class A, Class B, and some of these classes do not use SOTDMA. They use, let's say, carrier sense time division multiple access. Now, the construction of an AS firm. You see there is a 2,250 slots within 1 minute time frame, which means 26.667 milliseconds per slot. And each slot is it consists of 256 bits with a payload of 168 bit and ADLC NRG coding is used in this with an inversion on a 0. So this is an AIS GMSK modulator driven by continuous PRBS source in order to get excellent spectrum visibility. And for the last, the beauty of GMSK modulation is that it produces a constant envelope signal with zero light spectrum and low out of channel spectral content. Thus, it is a perfect signal for an RF amplifier with non-ideal characteristics. And with that, that's ends our discussion for today. Thank you.